Caching is a mechanism which is crucial for a seamless user experience, especially when you are building an app with both offline and online capabilities. With Kotlin Multiplatform, SQLDelight and Ktor, you can build scalable, efficient and offline-friendly applications that work well on both Android and iOS. In this video, we will cover the following: implementing the SQLDelight database on both mobile platforms, making network requests with Ktor, automatically caching the data whenever we fetch it from the network, and refreshing that same data every 24 hours. So for those of you who are not familiar, SQLDelight is a local database library that was built by a company named Square. It's a local database library which is fully available for a Kotlin multiplatform. With this library, you can write SQL queries and automatically generate Kotlin APIs accordingly. The SQLDelight plugin allows you to verify at the compile time your database schema, statements, migrations, and it also provides autocomplete and a refactoring feature, which makes writing SQL queries and maintaining your database more easier. I have already generated an empty KMP project that targets Android and iOS with a shared UI. First, we're gonna open up the version catalog file and declare all dependencies that this project will contain. So we have SQLDelight artifacts that we need to add for both Android and iOS source sets separately. Then we have Ktor dependencies as well as Kotlin X serialization. We're gonna need it to make a GET request and fetch some data from the network. Then we have a multi-platform settings library that should be used to persist a simple long value that we can later use to calculate and fetch the new data after 24 hours from the last network request. Then we have a Kotlin X date and time to interact with the current timestamp. And finally a coin library to handle a dependency injection in this project. Also, don't forget to specify those two additional plugins for Kotlin X serialization as well as SQLDelight. Next, inside the compose app gradle file, add the corresponding Ktor and SQL dependencies inside these two source sets. Plus the coin Android artifact in Android source set, because we're gonna need that for injecting the context. Afterwards, in the command main, let's add those other dependencies that we have already declared. Don't forget to specify these two plugins on the top, as well as inside the project level gradle file. Perfect. Now, one thing that you're gonna need before starting working with the SQLDelight is a plugin. So just search for a SQLDelight plugin and install that. So this plugin automatically generates Kotlin code for database tables and queries based on SQL files that you create. This reduces the boilerplate, which makes it easier to update database schemas and queries without manually writing an additional code. So after you install this plugin, go to the bottom of the compose app gradle file and define the SQLDelight configuration block. So here you need to add the exact same name of the SQDatabase file that we're gonna create later, as well as the package name in which that file should be located. That way, this plugin can know from which SQ file to generate type-safe Kotlin APIs. So whenever you rebuild this project, this configuration block will be executed along with some SQLDelight specific tasks to create additional Kotlin APIs that you define. So in the root of our command main, we need to create a SQLDelight directory with those same packages that we have defined in the configuration block. Then within that package, let's create here a new SQ file with the same database name as from the configuration block. So by having this SQLDelight plugin, you should be able to see that SQLDelight file creation option from the drop-down menu. Alright, so this database file should contain SQL queries for creating the database, reading, inserting, updating or deleting. Then those same queries will be translated into type-safe Kotlin functions that we can directly access from our code. Plus, when we are writing the query syntax, we will be able to see an autocomplete feature as well, which helps a lot. First, on top of this file, we need to define the schema of our database table. So we are using the SQL language to do that. If you are not familiar with that, there are a ton of resources that you can learn from. It's relatively easy. So you have noticed that I have added the not null keywords for each field in this table. Because if I exclude those two keywords, then this table will accept nullable types, which I don't want. After that, we can define a first SQL function that will be translated into the Kotlin function. So this one should be used to load or actually read everything from the database table. It's pretty simple. You can already see how this SQLDelight plugin is helping us with the autocomplete feature to write SQL syntax. The second function should be used to insert a whole object into the database. Here in the values block, just pass a question mark symbol for each field that we need to insert in this table. Because the SQLDelight plugin will afterwards generate a Kotlin function where we should pass those parameters explicitly. Great. So the last function that I want to create here in this file will be the one to clear our database table. We can trigger this logic when we are refreshing our database table with the new data. You can of course add as many functions as you need, but for now this is enough. Next, I want to create here a model class that should be used to fetch that same object from the network, but also to insert it into the local database. The name of this model class doesn't have to be the same as the name of the database table, just so you know. After you add all the fields that you want to fetch from the network, don't forget to add a serializable annotation, because otherwise we may get an exception while trying to fetch and deserialize this data in our app. For this project I have used the JSON placeholder API, and you can already see from this documentation what kind of fields I want to fetch from this same API. Also, don't forget to add the internet permission in the Android manifest file as well. I will quickly add one more additional class here in this project that will act as a wrapper class. So this will help us to gracefully handle an error in our application. And you will see about that later. So next, we want to implement the logic to fetch the data, or in this case multiple post objects, from the network. So create a new Kotlin class called PostAPI. Inside, I want to declare one constant that should represent a full endpoint. You may have noticed that I have included one extra parameter, which is underscore limit, to limit the number of post objects that we want to retrieve. Within this class, we need to initialize an HTTP client. So install the content negotiation plugin. It will help us to automatically handle various content types like XML and JSON during HTTP requests and responses. We are also configuring the JSON with one property that I often use in this situation. It's called ignore unknown keys. This settings allows the deserializer to ignore any keys in the JSON response that are not defined in our Kotlin data class. This is useful for APIs that may return additional fields that are not used by our application. After the HTTP client, we can create a suspend function to fetch the data from that endpoint on the top. Here I will also log one simple message for debugging purposes. So we're gonna use that to observe the order of function execution later. You will see about that. After that, we need to provide a platform-specific SQLDelight driver for Android and iOS. So this allows us to easily switch between platform-specific implementations in the app without worrying about the underlying details of how the database driver is created for each platform. So let's create here a new Kotlin file in which we can place an interface with a single function. This function should return the SQL driver. The SQL driver should later be used to query the database and access all the functions that were generated by the SQLDelight plugin. We're gonna implement this interface on an Android target first. Since we will be using the Android context to access the Android driver, let's add it here as a parameter. After that, implement the function from this interface and call Android SQL Driver. Here we need to pass the schema of our database table. So if you don't see here the name of the table that we have already defined in the configuration block from earlier, then be sure to rebuild your project first. Also, pass the context and the name of the database file. Perfect. Now goes the iOS platform. So here create the new class in the iOS main source set. In this specific target, we don't need the context object, so just pass the database schema as well as the name of the database file. Great. Finally, we can start on the database implementation. So I will create the new class in which we will pass the interface that we have just implemented on both platforms. Then, inside, we can create a database variable where we can call our PostDatabase class that was generated by the plugin. And we can pass the SQL driver to it. Below that, we need to create another variable that will hold the query object that we can use to interact with the database itself. So the first function that we need is the one to read everything from the database table. The return type of this function will be a list of multiple post objects. As you can see, this query object is able to access those same functions that we have defined in our SQL file. Because when we rebuild the project, the SQLDelight plugin should convert all those SQL queries from that file into the Kotlin API functions. We can call execute as a list function to get the list as a return type rather than a single object. Lastly, we can map those fields into a post object because if you recall, that SQL file contains only the fields of different types and not the whole post object. So there is also asFlow operator here as well, but for now I will just use a simple list. The second function will be used to insert multiple post objects into a database. So here we can use a transaction function that lets us insert each post one by one. Be careful because this transaction function can actually throw an exception. I am not gonna wrap this code inside the try and catch block because I will do that later in the place where I'm gonna call this function. The third one should be used to remove all posts from our database. So we're gonna call this one every time we need to refresh the data from the database. Great. Now that we have created both classes to handle the network operations and the local database, now we can create a new class or repository in which we will be able to inject those two classes and cache the data properly. As parameters, I will add those two classes plus the Multiplatform settings library. We're gonna use this settings library to save and read the timestamp value from the share preferences in order to calculate when to refresh the data. On the top, let's declare one constant that should hold the key under which we should save that timestamp value. So this class will hold the two functions. The one that will automatically fetch the data from the network and cache it locally, and the second one that should check if the data that we have cached is fresh or not. Let's implement that second one first. So here we want to retrieve that long value that we are gonna save in the share preferences after we successfully fetch the data. And we want to compare that save timestamp with the current timestamp. We're using here a Kotlin X date and time library to work with the date and time. So this function will return a Boolean value, true if it has been more than 24 hours since we have lastly fetched the data, or false if the data is still fresh. Now let's create a function that will be used to read the data from the database if we have cached the data, or to fetch it from the network and then cache it. So this function should be annotated with a throws annotation, because Kotlin treats all exceptions as unchecked, meaning that it doesn't require explicit handling or declaration of exceptions. Unlike Swift that uses a checked type error system where error throwing functions must declare potential errors. So in a Kotlin multi-platform project targeting iOS, adding this throws annotation to a function makes Kotlin aware that this function can actually throw exceptions, which allows the Kotlin native compiler to generate interoperability code compatible with the Swift error handling. Plus, this annotation tells the Objective-C runtime that the function can actually return NS error, which is actually bridging the Kotlin unchecked exceptions to a Swift checked exception models. Without this throws annotation, Swift and Objective-C would be unaware of Kotlin exceptions, and any errors thrown here would cause runtime crashes rather than manageable exceptions. So this function should return a post list wrapped inside the request state wrapper class, because we need to properly handle the error case. Inside this function, we can wrap the code in a try and catch block, because that function for inserting the data in the database can actually throw an exception. So first, we are reading the data from the database. The database should act as a single source of truth. That way, we will not make any extra network request if not necessary. So if the data doesn't exist in the database, only then we are fetching the data from the network and immediately caching that data locally. You can also see that we are using that useful Kotlin scope function called also. It's really handy. Plus, we are persisting that long timestamp value so that we can later calculate whether the data is stale or not. In other case, when we already have a data in the database, first we are checking if that data is stale, and if it is, then we are refreshing that data by triggering a network request once again. Otherwise, we are returning an existing data from the local cache. Of course, if something bad happens, we are returning an error. Now that we have declared the local database, API, and the repository class, we can finally focus on a dependency injection to provide all these parameters. In the common main, we can create a new function that will be used to initialize coin library. We will need to do it separately on Android and iOS. That's why I'm gonna add this configuration parameter, because on the Android target we will need to configure and pass the context object, while on the iOS we don't need it. Plus, on the top I will declare one expect variable that should represent a coin module. This module should be also implemented separately on each platform. Now generate a platform-specific implementations, and first let's go with Android. Create an application class first and override on a create function, because here we need to initialize a coin library as well as pass our application context to this configuration block. Don't forget to add this class in the Android manifest file afterwards, and we're good to go. Next, we need to implement that target module and declare all dependencies. We want to create a singleton for the PostAPI, then for the settings. Then we need to provide that common database driver factory. In this case, that's the Android implementation that we have defined. It accepts a context as a parameter, which is why we can call this Android context function from the coin library, since we have already provided this context within the application class. Next, we have the local database, so this one accepts that driver factory as a parameter, and since we have already described how to provide it, we can just call this get function that will automatically find and inject that declared type. After that, we can call a PostSDK, where we can pass all those three dependencies, since we have defined them here as well. There is just one more type that we need to declare here, and that will be the ViewModel. So first, go ahead and create the new ViewModel class. For now, just add here the PostSDK as a parameter. Then let's go back to that target module and provide it. So for the iOS target module, we need to do pretty much the same thing, except for the database driver factory. Here, we need to initialize that iOS implementation instead. Lastly, we need to call that initialize coin function here in the iOS main source set as well, and we can just pass here the config parameter that should trigger once the application starts. Now, one thing that could be improved here is to move all those same dependency declarations in the common coin module and leave only the database driver factory inside the target module, because that's the only class that we need to define separately for each target. So just go back to that shared coin module, create a new shared module variable, and pass all those same shared dependency declarations. Don't forget to include this new shared module down below in the modules function, and we're good to go. Let's quickly implement that ViewModel from earlier. And here inside I'm gonna create the new variable. I'm gonna also use a type alias, since the type of this variable is a little bit longer. We are wrapping this request state within the mutable state wrapper. Then down below I will set here a default value to be request state idle. So when we are initializing the ViewModel, we want to read those posts from the database right away. And we have already encapsulated the logic in this PostSDK to fetch the data from the local database, and if the database is empty or the data is stale, only then we want to fetch here the new data from the network. Finally, we can handle the UI. So first I want to initialize the ViewModel. We can use a coin ViewModel function, because we have already described how to provide an instance of the ViewModel and pass this parameter. After that, we can observe that single property from the ViewModel. And down below, let's create some simple UI. So if the data is fetched successfully, we want to display those information in a lazy column. Otherwise, if the data is of a type of a request state error, then we just want to show here a simple error message on the center of the screen. Great. We can launch the application now and observe the logcat so that we can see which function is gonna be triggered first. So before we launch the application, let's quickly go back to the coin module and add one more singleton that we have forgot to do earlier. For the local database, of course. Great. So when the application is launched, we are first reading the local cache to see if there is a fresh data that we need to load. In this case, the cache is empty, which is why we need to trigger the network request. After the data is fetched, we are immediately caching that data locally. If we try to launch this application once again, this time we are only gonna read the local cache data, because there is already a fresh data in our database. Only after 24 hours pass, only then we will be able to refresh the data. The last thing which I want to show you in this tutorial is how to properly migrate SQLDelight database to a new version or to a new data schema. So let's say that we want to add an additional field or a property in this existing table. I'm gonna add here a default value, which will be an empty string. That's the safest way to proceed, because we will be able to use default value for that old data in our database that doesn't have that thumbnail field. After that, we need to create the new directory inside the same folder as our SQL database. So that new directory needs to be called migrations, because that's a default place where the SQLDelight plugin will search for potential migrations. The file name should be a version number of your database from which you want to migrate away. In this case, since our original database table has an initial value of 1, we want to set the name of this file to be 1. The file extension of this file is SQM, by the way, and here I will quickly write the SQL query that is used to alter our database schema by adding an additional column with a default value of an empty string. After that, feel free to rebuild this project. Don't mind if you're seeing this error right here in this file, because everything works fine. Then we need to add an additional field in our post model class. After that, be sure to pass some default value for the thumbnail for now. And we have forgot to add a thumbnail field in our insert post SQL query. So let's just do that quickly. Great. Don't forget to include the thumbnail value in the UI of your application, and we can launch the application again. Also, let's remove this application and launch it all over again. You will encounter one error while fetching the data from the network, because our PostModel class is looking for that thumbnail property in the API response. Since that property doesn't exist in the API, we need to tell the deserializer to ignore that single field. We can do that by using the transient annotation and providing a default value for it. Finally, I will replace that hard-coded thumbnail value in the LocalDatabase class, and we can run this application once again. Feel free to remove this application from the emulator and launch it all over again. As you can see, this time everything works fine. Even though we have reinstalled the application, the migration works as expected. And that's it. That's how you can easily cache your data and enable offline capabilities for your app, using Ktor and SQLDelight libraries for a Kotlin multiplatform. If you have any questions, feel free to comment down below. Don't forget to leave a like to this video if you find it helpful, and thank you for watching.
I'm a legend when they lay me down to rest.